Hello students, today we will discuss more about ordinary ray and extraordinary ray. So ordinary ray and extraordinary ray are the two rays we have seen in a doubly refracting crystal. So ordinary ray, as we have mentioned, it will be following conventional law of refraction, and it has vibration of electric vector perpendicular to the principal section, and it will be traveling with same speed in whatever direction it is incident or it is refracted. In whatever direction they are moving, they will experience the same speed. And why they are moving with same speed? Because for them the refractive index in any direction is the same. So refractive index is constant in all direction, and hence it will have same speed, and they have vibration of electric vector perpendicular to the principal section, and hence the name ordinary ray. And it is just the same ray we obtain in a conventional refraction. Okay. And while extraordinary ray, it do not follow conventional laws of refraction like Snell's law, and other laws of refraction are not followed by extraordinary ray. It has vibration of electric vector parallel to the principal section. That is the primary distinction between ordinary ray and extraordinary ray. And another distinction is that they have velocity different along different direction. As we have mentioned, it is an anisotropic crystal, so in all directions, whatever be the direction, the appearance will be different. So and hence this particular ray, which vibrates parallel to the principal section, will feel the velocity as different along different direction. Why is that so? Only because refractive index for extraordinary ray varies with direction. So based on second point, you can consider ordinary ray and extraordinary ray are plane polarized because they contain the vibration either parallel or perpendicular, and hence ordinary ray and extraordinary ray are said to be plane polarized. And another inference is that though extraordinary ray has different velocity and different direction along the optic axis, it will have the same refractive index as that of the ordinary ray. So it will have the same speed as that of the ordinary ray along optic axis, because it is the axis or direction in which the crystal will appear as symmetric. അപ്പോൾ അതിലൂടെ ആ ഡയറക്ഷനിൽ whatever be the ray that is passing, it will experience the same speed. So when light falls normal to the optic axis, so the first case, let us consider we have optic axis, we have a crystal with optic axis like this. Let this be the direction of the optic axis. Now let us consider the light is incident normally onto the optic axis. So what will happen if it is along the same direction? What we have just mentioned is that if optic axis is like this and if the light incident is also in the same direction, then what will happen? The ray emerging, ray passing through the crystal will not undergo any splitting. Karanam, they are having same velocity. Whether it be ordinary or extraordinary, they have same velocity. So no splitting of light will happen. They will proceed as a single ray. No double refraction will happen. But if the incident light is falling normal to the optic axis, they have a different velocity. So they will, that is ordinary ray and extraordinary ray will be moving along the same direction, but maybe ordinary ray will be preceding the extraordinary ray, or it could be ordinary ray following the extraordinary. So it will depend upon the kind of material it is. Okay, so whenever the light is incident normal to the optic axis, then no splitting is there as extraordinary and ordinary, but they are moving in the same direction. So ഒരു സെയിം ഡയറക്ഷനിൽ പോകുന്ന രണ്ട് വേവുകൾ തമ്മിൽ ഇഫ് ദർ ഇസ് എ ഡിഫറൻസ് ഇൻ വെലോസിറ്റി ഒരു പോയിന്റിൽ എന്ത് സംഭവിക്കും? ഇഫ് യു കൺസിഡർ ദിസ് പോയിന്റ്, ഓർഡിനറി റേ വുഡ് ഹാവ് ക്രോസ്ഡ് വൺസ് എക്സ്ട്രാ റേ അറൈവ്സ് ഇറ്റ്സ്. സോ ദർ ഇസ് എ പാത്ത് ഡിഫറൻസ് ബിറ്റ്വീൻ ദം. അല്ല, നമ്മളൊരു ഓട്ടത്തിൽ നോക്കുവാണെങ്കിൽ രണ്ടുപേര് രണ്ട് വെലോസിറ്റിയിൽ ഒരു ഡയറക്ഷനിൽ പോവുകയാണെങ്കിൽ ഫസ്റ്റ് എത്തുന്ന ആളും സെക്കൻഡ് എത്തുന്ന ആളും തമ്മിൽ ഒരു പാത്ത് ഡിഫറൻസ് ഉണ്ടാവും, അല്ലെങ്കിൽ നമുക്ക് പറയാം ഒരു ടൈം ഡിഫറൻസ് അല്ലെങ്കിൽ ഫേസ് ഡിഫറൻസ് ഉണ്ടാവും. സോ ദ സെയിം തിങ് ക്യാൻ ബി നോട്ടീസ്ഡ് വെൻ വി കൺസിഡർ ദ ലൈറ്റ് ഇസ് ഇൻസിഡൻറ്റ് normal to the optic axis. Now the next point is when the light falls parallel to the optic axis, no splitting will happen because they are passing along the optic axis, therefore they will experience same velocity. So no double refraction will happen. So that point has to be remembered. That is, there are conditions where no double refraction will happen, and there are conditions where there will be a phase difference arising due to the difference in velocity, but they travel in the same direction. So corresponding to that, we get different types of polarized wave. We'll see it later. Now, so as we mentioned, the distinction of being ordinary ray, that is being perpendicular to the principal section, and extraordinary, that is whose electric vector vibrates parallel to the principal section, exist only within the crystal. Why that so? Because principal section can be considered only inside the crystal, isn't it? It was a plane containing the optic axis and perpendicular to the opposite faces. അപ്പോൾ പ്രിൻസിപ്പൽ സെക്ഷൻ എന്ന് നമുക്ക് പറയാവുന്നത് ക്രിസ്റ്റലിൻ്റെ ഉള്ളിൽ മാത്രമാണ്. പുറത്തെടുക്കുമ്പോഴേക്കും we don't have any reference whether the ray is vibrating perpendicular or whether it is vibrating parallel to something. Okay, so that terminology as ordinary ray and extraordinary ray exist only within the crystal. So whenever the ray is outside, it differ only in the direction and polarization. We cannot call them as ordinary or extraordinary. They will be considered as P rays and S rays, that is parallelly vibrating electric vectors and perpendicularly vibrating perpendicular vectors. So Christian Huygen has given an explanation for this double refraction. So he considered that whenever a light source is there inside an isotropic medium, if there is an isotropic crystal ഉണ്ടെങ്കിൽ all directions crystal has a symmetry, isn't it? So when there is a light source inside that crystal, it will be producing the same, or the light will be moving with same velocity in all direction. So what you get will be like a spherical wavefront എന്ന് പറഞ്ഞാൽ നമ്മൾ ഇങ്ങനെ ഓർത്താൽ മതി. That is when we put in a rock or pebble into the water surface, you can see that ripples are proceeding in all directions, right? Why you are feeling that ripples? Because in all directions the disturbances are moving with same velocity. So that means that will constitute the wavefront will be a circular one. Similarly, in a crystal it is a three-dimensional one, so instead of circle you will have a spherical wavefront. So this is the case of a isotropic crystal where the light where the crystal has symmetry in all direction. എല്ലാ directionലും atoms are arranged in the same way. But what we are considering is a doubly refracting crystal, which is actually an isotropic crystal. So in that case, each point in the crystal, each point, if a light is incident, it will behave as a source. നമ്മൾ പെബിൾ ഇടുന്ന പോലെ തന്നെ it will behave as a source of two wavefronts. Why two wavefront? One is for extraordinary and other is for ordinary ray. So since and I can mention that one will have a spherical one and other will have a um, um, elliptical one. Okay, so one wavefront will be spherical and other will be elliptical. Why? Because spherical wavefront is obtained for those rays which are moving with same velocity in all direction. So which is that ray? Yes, it is the wavefront for ordinary ray because it moves with same velocity in all directions. While you'll get a ellipsoidal wavefront for extraordinary ray. Okay, so the velocity of ordinary ray is constant in all direction and hence you'll get a spherical wavefront emanating from the source, while the velocity of extraordinary ray will varies with direction and hence you can expect a ellipsoidal wavefront. And they will be touching at 2 points because we have mentioned whenever we consider a direction of symmetry which is called optic axis, then velocity of ordinary ray and velocity of extraordinary ray will be the same. Therefore, these two wave surfaces will touch each other at 2 points and the line joining defines the direction of optic axis. Because you can see that there will be two locations like this. It will be touching extraordinary rayum touch ചെയ്യാൻ പോകുന്ന velocity points ഉണ്ടാവും. This is the wavefront due to ordinary and other is due to the extraordinary. So you can see that whenever there is the light is traveling along the direction of optic axis, ഈ ഡയറക്ഷനിൽ വരുമ്പോൾ ഇതാണ് സോഴ്സ് പോയിന്റ് എങ്കിൽ ഈ ഡയറക്ഷനിൽ വരാൻ പോകുന്ന വെലോസിറ്റി for extraordinary and for ordinary are the same. So they will those two surfaces will touch each other along the optic axis. Similarly, നമുക്ക് ഇങ്ങോട്ടും ഒരു ഡയറക്ഷൻ ഉണ്ടാവും. So those two touch ചെയ്യുന്ന പോയിന്റ്സ് നമ്മൾ ജോയിൻ ചെയ്ത് കഴിഞ്ഞാൽ it will be the direction of optic axis. Okay, so these are the four postulates put forward by Huygen to explain double refraction. So the first point is that if it is an isotropic medium, each point in the crystal will act as a source of one wavefront, which will be a spherical wavefront. But what we are considering is an isotropic crystal, and here each point will be a source of two wavefront. One for extraordinary ray, which has different velocity along different direction, and hence it is have a ellipsoidal appearance, while the other is for ordinary ray, which is having a velocity constant along all direction and hence it will have a spherical wavefront. And these wavefronts will touch each other along the optic axis because along the optic axis ordinary ray and extraordinary has same velocity. അതുകൊണ്ട് those surfaces or wavefronts will touch each other. Okay, so as we have mentioned, it could be like one way. There are two kind of crystals based on the concept of refractive index or how much velocity it has. That is, in some cases ordinary ray may have more velocity than extraordinary, or in some other case extraordinary ray will have more velocity than the ordinary. So based on that you have two kind of crystals. So this is also a postulate given by Huygen. So whether it is a positive crystal or negative crystal, the terminology is given by the term birefringence, which is just difference of refractive index between that of extraordinary and that of ordinary. Mu e minus mu o birefringence term എന്ന് പറയും. So depending upon whether it is positive value, you will call such a crystal as positive crystal, and if it is a negative value, then we call such a crystal as negative crystal. Okay, so we designate a crystal on the basis of birefringence term. From this expression itself, you can see if mu E is greater than mu O, this difference will be a positive quantity and hence a name positive crystal. While if mu E is less than mu O, the quantity will be a negative one and hence a name negative crystal is given for that kind of crystal. Okay, and so that is how you get the name. And another point to be noted is that, so first then you have to mention about the refractive index. Then you can mention about velocity. If the refractive index varies, then velocity also varies, and you know refractive index is inversely proportional to velocity. So for a negative crystal, if mu A is less than mu O, then in terms of velocity it will be velocity of extraordinary ray will be greater than velocity of ordinary ray, and it is on this basis a wavefront is drawn. A wavefront of extraordinary ray will be moving faster than the wavefront due to ordinary ray. So which means you can draw a wavefront like this. Extraordinary ray, the ellipse ഉണ്ടാകും, അതിൻ്റെ ഉള്ളിലായിട്ട് you'll get ordinary ray, and as mentioned here, velocity of E is greater than VO, so ellipse ആയിരിക്കണം outward and inward it must be spherical. അപ്പോൾ ഇവിടെ നിന്ന് ഒരു റേ എത്ര സമയം കൊണ്ട് ഒരു പർട്ടിക്കുലർ എത്ര ഡിസ്റ്റൻസ് ഒരു പർട്ടിക്കുലർ ടൈമിൽ കവർ ചെയ്യുന്നുണ്ട്, that is velocity. So that will constitute a spherical wavefront if it is having same distance along all directions. And how much is the distance traveled by the extraordinary ray along the same direction in that particular time will constitute an elliptical wavefront. So you can see that ellipsoidal wavefront and the spherical wavefront will be touching each other at 2 points, and the line joining those 2 points is the optic axis, because it is a direction along which whether it be extraordinary or ordinary ray, they will be moving with same velocity. That is why they touch each other. Okay, similarly you can explain for positive crystal. Since mu E is greater than mu O, we have to mention the velocity of extraordinary ray will be less than the velocity of ordinary ray. So which ray will be inside? Ellipsoid will be inside the spherical wavefront. So here you can see. Okay, so in order to memorize it, you can imagine PO is O. Okay, so O, ordinary ray wavefront, spherical wavefront is outside, and inside is ellipsoidal wavefront. And you cannot draw it like this. I cannot draw it like this. Why? Because optic axis ഏതാണോ ആ ഡയറക്ഷനിൽ വേണം ഇവിടെ ടച്ച് ചെയ്യാൻ. If I draw like this, it will touch a point which is direction which is perpendicular to the optic. That is not possible. That is why you can draw the wavefront representation for a positive crystal as like this only. A negative crystal is very easier to remember. It appears like, you can imagine it as a shape of an eye. Okay, so those are the basic things you have to mention when you differentiate between positive and negative crystal. First thing is you have to mention how a name is obtained for a crystal as positive or negative based on birefringence term. So from that term itself, you can see that mu E will be greater for a positive crystal while smaller for a negative crystal. So based on that, you can then expand on to velocity. Since velocity is inversely proportional to mu, you have velocity dependence. Then based on which we will consider a wavefront. The wavefront ആണ് ഇവിടെ വരച്ചിരിക്കുന്നത്. So wavefront due to extraordinary ray will be proceeding faster than wavefront due to ordinary ray. So that is how it is drawn. So you have to draw the wavefront also. So that explains the difference between ordinary and extraordinary ray, and explanation of Huygen's concept on double refraction, as well as distinction between positive and negative crystal. Hope you have understood. So let us wind up for the time being. Thank you.